Example 9. Approximate cube root of 7 by using Raphson methods and the initial value of 2 up to second iterations. Give your answer correct to 3 decimal places. So in these examples here, I do some modifications or compared to the original questions where I would like to specify that the final answer I want to have 3 decimal places. And let's see how we happen to solve this question here by approximate a irrational number using Raphson methods. And in here, you will happen to tell that the initial value of 2, which is referred to our first approximations that we're going to use later. One more thing I need to take notes in this question here is that the stopping criteria, where according to this question, the stopping criteria is that we're just going to do until second iterations, which means that we're going to apply the Raphson formula for calculations only for twice. And let's see how the calculations is going on to do the approximation here. So first of all, what we're going to do is that let us do an assumption where we consider x is equal to the cube root of 7, where later the x that we're going to solve from Raphson methods will corresponding to the cube root of 7 that we want to find its approximate value. Then from this x equals to cube root of 7, we cube both sides, we power up 3 both sides, it gives us x power of 3 equals to 7. Rearrange it, you happen to find out that it forms an cubic equations where we have x cubed minus 7 equals to 0. And now we make use of these equations here, solve the x in these equations here in order to find out the approximation value for the cube root, where we solve the x value from this equation here is actually corresponding to the cube root of 7. Therefore, in such formations here, we have all the terms on the left equal to 0. So I will make the left hand side terms here be some functions. Let's say we call the function as function fx. Then, based on what we happen to know in Raphson method formula, let's recall xn plus 1 equals to xn minus fxn divided by f prime xn. So based on this formula here, we need to identify the f and also the f prime. Therefore, the next thing what we're going to do, after we identify the fx, we find out the f prime. Then with this fx and f prime here, later in our iterations, the framework will happen to be referred to something like this. Xn plus 1 equals to xn minus, so what we have here, fxn, which is referred to x to the power of 3n minus 7 divided by 3x n squared. So this is the framework later we're going to apply for the calculations for using Raphson methods. And in order to make our calculation later fast enough, let us insert this framework here into the calculator, where we happen to have x minus the fraction terms here. I have x cubed minus 7 divided by 3x squared. So we get ready this framework here to apply Raphson calculations. Then now, according to the questions, you happen to tell that the initial value is equals to 2, which means that we're going to have our first approximation x1 equals to 2. Then next, we go on with the calculation. For the first iterations, we will have x2. Substitute 2 in according to this framework here, where all the xn here, we're going to substitute with 2 now. So this is the result that we have. And what is the corresponding value after we perform these calculations here? We can get the answer from the calculator in such way that after you insert this function inside, we press calculate, insert the value of 2. So insert 2 equal. So this corresponding result 23 over 12 will be happen to be the result for x2. And since the final answer I want it to keep into 3 decimal places, so let us have our result here. Let us have our result here to be 4 decimal places. So according to the result here, I have 1.9166666, so on and so forth. If I want to keep the answer into 4 decimal places, it will be 9167. So therefore, this is the result we have. Continue. The question requires us to do 2 iterations, so now only we have the first iteration to get x2. Let us continue with the second iterations to get x3. So for x3, the calculation will be, we substitute the result from x2 into the framework we have, and this is the corresponding result we have. x2 minus the cube of x2 minus 7 over 3 times x2 power of 2. And to perform this calculation to get the result from calculator, we continue with pressing the button calculate. And once again, we are not going to insert manually 1.9167 into calculator, but instead, we just enter the answer button that equal. So this is the corresponding result that we're going to have for x3. And we just want 4 decimal places for writing. So it will be 1.9129 as is shown here. And therefore, in this question here, if you try to refer to the result that we have, by the time I round off into 3 decimal places, you see that the answer is 1.917. The other one is 1.913. Although the answer of the round off value is not the same, but we need to stop our calculation at this moment here for second iteration, because this is the requirement of the question. They just want to up to the second iterations. So therefore, we stop at second iterations and then use the result of the second iteration, which is x3, round off to 3 decimal places for answer. And from there, you happen to find out x equals to 1.913. And take notes, the final answer we want to achieve here is not x, but we want to answer back the approximate value of the cube root of 7. So therefore, based on the assumption just now, x is equals to the cube root of 7. So therefore, I have cube root of 7 is equals to 1.913. And this is the answer correct to 3 decimal places. So this is the solutions that we can do for this example.